Okay, for problem 45, we need to solve 44 first, so we'll do sort of both of these problems. And I've sketched out the diagram. So here's Kirby over here, and we're going to make him the origin of our coordinate system. And he hits the ball, and at the time he hits the ball is 4 feet off the ground. That's a 4. And it's traveling with a velocity of 120. I won't write in units here. You know the units. 120 feet per second at 30 degrees. And so classically, you want to find the position of the ball after a certain amount of time has passed in terms of the coordinates x and y. And so x, and we want to find them as a function of t. So x is a function of t and y is a function of t. Okay. And we have to remember gravity as a factor. But apparently for these problems you can ignore air resistance. And that's relevant later. But we're just assuming that this 120 feet per second here is constant. And so the distance traveled, the total distance traveled by the ball is always going to be 120 feet per second times t. That's the total distance. And so the x-coordinate is going to be x equals 120 t times cosine of 30 degrees. And y is going to equal, well, first of all, it starts at 4, so 4 is a constant. We'll put that in there right away. 4 plus 120t times sine 30 degrees. But we have to subtract its rate of falling towards the center of the Earth, which is 16t squared. That comes from the general formula. When there's acceleration, the change in position is 1/2 acceleration times t squared, 1/2 at squared. That's the general formula. Here a is gravity, the constant for gravity, which is g, which is 32 feet per second, and 1/2 of that is 16. So that's where the 16 comes from. Okay, so those are our general formulas, and let's apply that. Oops, sorry. Let me copy these formulas onto the next page in just a minute, and we'll start our solution.